Here's a simple question. If you had to refactor a million-line codebase or prototype an autonomous feature next quarter, would you trust an open model to help you ship? Not just to demo, but to do the real work. So, the story this week is that open source and open weight AI just took a very practical step forward. We saw a new open coding model that tackles messy repositories, a reported open model for autonomous driving decisions, and tools that let a friendly assistant fine-tune big open models for you. In other words, OpenAI isn't just catching up, it's specializing. Let that sink in for a second. The pitch isn't cheaper ChatGPT. It's purpose-built, auditable, and under your control. Here's what actually matters here. If you work around code bases, regulated data, or physical systems, the options are widening. Your next coding agent or AV prototype could run locally, be inspected line by line, and avoid vendor lock-in. That's a big deal. Now, quick orientation before we go deeper. Mistral announced a pair of open-weight coding models called Devstral 2, plus a terminal agent. NVIDIA reportedly introduced an open vision language action model for mobility. Think cars that can see, reason, and act. And Hugging Face launched a workflow where Claude, the assistant, orchestrates fine-tuning and deployment of open models up to very large sizes. We'll unpack what those mean without drowning in specs. The key idea: open models are shifting from general-purpose toys to specialized tools. So what actually happened? According to Mistral's own announcement in docs, Devstral 2 is their new coding model family designed for real repositories, not just snack-sized coding puzzles. The flagship model has 123 billion parameters, which is one way of saying it has a lot of capacity. More importantly, it can read long stretches of code, up to what's described as a very large context window, so it can keep track of many files at once. It reportedly reaches 72.2% on something called SWE Bench Verified. Quick pause. SWE Bench Verified is a benchmark where models try to resolve real GitHub issues in messy repos, with tests verifying the fix. In other words, it's closer to fix this bug in the wild than answer a trivia question about Python. Mistral also released Devstral Small 2, a 24 billion parameter version under a permissive license. The point there is you can run it on good consumer GPUs, so teams can keep code on-prem and still get the smarter behavior. They also shipped the Vibe CLI, a command line agent that can navigate a repo, make multi-file edits, and generally act like a tireless engineer running Git and an editor. On costs, Mistral claims their open coding model is significantly cheaper to run than some closed rivals. Reports say roughly 7 times in some cases. Your mileage will vary, but the direction is clear. Performance good enough for work, price low enough to try broadly. Now, on the mobility side, bulletins report NVIDIA released something called Alpamayo R1, a vision language action model aimed at autonomous driving. Vision language action, or VLA, means a model takes in visual and text inputs and outputs actions, like turning, braking, or high-level driving commands. We'll be careful here. Details are from secondary sources, but the claim is that Alpamayo R1 is open and industry scale, meant as a foundation you can audit, fine-tune, and run on NVIDIA's stacks. If you're a Tier 1 supplier or a robotics startup, that promises faster prototyping without a closed black box in the loop. And then there's tooling. Hugging Face announced Skills for Claude, where the assistant can orchestrate fine-tuning of open models end-to-end. You describe what you want. It spins up cloud GPUs, monitors the job, and pushes the finished model back to the Hugging Face hub. It reportedly supports models from around 500 million parameters up to 70 billion, and can convert to formats like GGUF for efficient local use. In other words, Claude acts like a project manager for your ML ops, but the models you're training remain open and under your control. So let's slow that down for a second. 3 threads, 1 pattern. Open models that are purpose-built for jobs, and friendly tooling that makes them usable by regular teams. How do these models actually work in practice? Take Devstral 2. Under the hood, it's a dense transformer. That's the standard large language model architecture, without fancy sparse tricks. The important part isn't the buzzword, it's the behavior. With a very long context window, the model can keep more of your repo in its head. Imagine walking a monorepo with a flashlight versus flipping on the stadium lights. Longer context means fewer trips back and forth, less forgetting, and more coherent edits across files. Mistral also leaned into agent patterns. The Vibe CLI isn't just a chatbot, it's an operator. It searches the repo, opens files, writes patches, runs commands, and can iterate when tests fail. Think of it like an IDE on autopilot, but wired into your terminal. Devstral Small 2 takes that same intent, scaled to fit commodity hardware. It reportedly handles code plus images, so it might parse a diagram or UI screenshot to inform changes. That's helpful when specifications live in Confluence slides rather than README files. On the fine-tuning side, the Hugging Face plus Claude combo is basically GitHub Actions for model training. You describe the target model, data, and strategy. Claude creates training jobs on GPUs, keeps an eye on metrics, and ships artifacts to the hub. Converting to GGUF matters, because it unlocks fast local inference on consumer GPUs or edge devices. No giant cloud bill, no compliance headache. And a quick note on the VLA idea with Alpamayo R1. Vision language action models fuse what the camera sees with instructions or goals, then output actions the system should take. In a car, that might mean interpreting a complex intersection with construction signage and deciding to slow, yield, or change lanes. The open angle is less about bragging rights and more about accountability. You can audit data, check failure cases, and build shared safety tests. Here's the thing people sometimes miss. None of this requires the open model to beat the latest closed frontier system on every benchmark. It just needs to be good enough for your task and adaptable enough for your constraints. So why does this matter now? For software teams, you can run a credible coding agent inside your network. Your code doesn't leave your environment. You can version the model alongside your services, and per Mistral's own comparisons, you can reduce cost meaningfully. For automotive and robotics, an open VLA baseline, if it bears out, means faster iteration, shared safety research, and tighter integration with your hardware stack. For any data-sensitive org, the orchestration pattern lets you get the polish of a closed assistant while keeping the trained models open, portable, and deployable where you need them. The key thing here is that value is drifting up the stack. Raw model prowess still matters, but the differentiators become your data, your workflows, and your safety envelope. On top of open, swappable models, let's talk risks and open questions, because they're real. Performance gaps. Even strong open models can trail the very best closed models on some tasks. Mistral's Devstral 2 reportedly outperforms some popular open rivals, but still trails closed leaders on certain evaluations. In practice, that means you'll want guardrails, tests, code review, staged rollouts around any agent making code changes. Safety and governance. When thousands of teams fine-tune their own models, safety doesn't live in one place anymore. A model fork tuned on one dataset might develop odd behaviors. This is where shared evaluation suites, red teaming, and incident reporting become important. Open helps here. You can actually inspect and reproduce, but it still requires discipline, unverified details. With Alpamayo R1, much of what we have is from secondary sources. The open claim is promising, but the proof is in documentation, datasets, and real-world validation. For now, treat it as a noteworthy signal, not a settled standard. Deployment friction. Running locally is attractive, but fine-tuning large models still needs GPUs, strong MLOps, and patience. The Claude as orchestrator pattern can lower the bar, but it doesn't make the hardware go away. So, where's this going? I'd watch 3 shifts. Vertical stacks. We'll see open models tailored to domains, coding, mobility, healthcare imaging, industrial inspection, bundled with agents and tooling tuned for those jobs. Hybrid ecosystems. Closed assistants act as the UX and control plane. Open models do the heavy lifting under the hood. That reduces lock-in and makes model choice more of a runtime lever than a one-time bet. AI Ops gets agentic. Spin up a fine-tune, evaluate on our internal suite, convert to GGUF, and deploy to the edge becomes an instruction you say out loud, and the system does the wiring. The hard part shifts to data quality and oversight. Let that sit for a moment. If choosing a model becomes a reversible choice, organizations can iterate faster and align models more closely with their own data and constraints. A few practical takeaways if this touches your work. If you're a software leader, pilot an open coding agent on an internal repo with strong tests. Track the kinds of tasks it accelerates. Refactors, dependency bumps, boilerplate, and the failure modes. Cost per useful change is a better metric than raw benchmark scores. If you handle sensitive code or data, map your compliance posture to deployment options. Self-hosted inference, on-prem fine-tuning, or a hybrid where a closed assistant orchestrates but never sees raw data. Open models plus GGUF give you options at the edge. If you're in mobility or robotics, look for open VLA baselines and reproducible evaluation suites. Even if you stick with your in-house stack, open references can sharpen your safety practices and give you a shared language with regulators and partners. If you're a platform or product owner, plan for interchangeability. Treat models as components. Can you swap a coding model without breaking your developer workflow? Can you retrain a smaller variant for a latency-critical path? If you're new to fine-tuning, start small. A 7B or 13B model tuned on your domain data, deployed locally, can teach you more about data curation and evaluation than a giant experiment you can't run twice. Here's what stands out for teams in this space. Specialization beats scale when the problem is narrow and the constraints are hard. Open models are competitive because they can be bent to those constraints, on your hardware, with your data, under your rules. Let's bring it home. Open source AI isn't just the free version anymore. With models like Devstral 2 aimed squarely at professional coding, with reported open VLAs for driving, and with orchestration that lets assistants train and ship open models, we're seeing open move into production. The promise is less about beating every benchmark and more about control, cost control, data control, and the ability to audit and adapt. If you're exploring this space, focus on fit over hype. Does the model read your repo without getting lost? Can you reproduce a driving edge case across teams? Can your assistant launch a tuned model and convert it to a format your hardware likes? And remember the framing. Innovation is drifting to the layers above the base model. Your workflows, your safety practices, and your integration choices are the moat. Open models are the infrastructure under that moat. That's the story for now. If this was helpful, a like and subscribe helps us keep making these videos. Thanks for watching.